Hello.
Hi, welcome back. Yes, anything new today?
New haircut.
Huh?
New
Wait,
haircut.
I haven't have a look at you because I look at the screen. New haircut. Is it undercut?
What?
Is it what is the style of it? It's like undercut or something?
No, not. It's not style. I felt too hot, and I decided to like cycled to the barbershop and told the barbershop owner to cut
Ah,
sh- my hair short.
uh-huh. Okay, I see. So like based on your no your old hair. So like yeah, just make it shorter. How much does it cost you?
40.
40. Okay, I think it's reasonable, but it's yeah. Okay. Do you usually have your family members, like your mom, your dad, cut your hair
No, only for once.
for once, and now never?
Yes.
Okay, who cuts your hair?
The barbershop owner.
No, I mean like before. Your mom and your dad cut your hair already, right?
Yes.
Mm. And how was it?
It was bad.
It was bad. And you know what? During COVID-19 pandemic, you know what? At that time, there was like the shutdown, and nobody could go anywhere, right? Even going to the market. So I bought um a hair trimmer, lấy cái tông đơ còn the hair trimmer to trim the hair for my
Son.
husband. No, my husband. To trim the hair of my husband. The first time I did it well, and he even called his mom to show the new haircut. But the second time, like I lost my feeling. I couldn't make it again. So it was very terrible. So since then, I didn't cut his hair anymore. Yeah. Okay. Angie, do you know any countries that are very sensitive to earthquakes?
Japan.
Yes. And
China.
mm, China. And there's um there's a country in Southeast Asia that's you can hear that they have earthquake almost every year.
Indonesia.
Yes,
Indonesia.
yes, Indonesia. Yes. Mm. Mm. And any other?
Myanmar.
Mm. Okay.
And Malaysia.
Malaysia. Okay.
I think that's all.
That's all.
And maybe Vietnam too, because Vietnam, each year Vietnam always have earthquake, but
Mm-hmm.
very little.
Yes. Like a couple of like last year, there was a slight, very slight earthquake. It's because the earthquake from Indonesia, right? Oh, it was very deadly. Um, okay, I actually we didn't want it to happen because it can cause a lot of death tolls and damages to peoples and cities. But yeah, let's have a look at top five deadliest earthquakes in the world. Okay, and after you watch this one, can you summarize for me the top five? It recognizes every speaker. Do you see my screen?
No,
How about now?
a dark screen.
A dark screen. Okay.
Hello, today we will talk about the largest earthquakes in history. Earthquakes are caused by movements within the Earth's crust and uppermost mantle. They range from events too weak to be detectable except by sensitive instrumentation, to sudden and violent events lasting many minutes which have caused some of the greatest disasters in human history. Number 1. The 1960 Valdivia earthquake. Various studies have placed it at 9.4 to 9.6 on the moment magnitude scale. It occurred in the afternoon on May 22nd, and lasted approximately 10 minutes. This was the most powerful earthquake ever recorded. The resulting tsunami affected southern Chile, Hawaii, Japan, the Philippines, eastern New Zealand, southeast Australia, and the Aleutian Islands. Number 2. The 1964 Alaskan earthquake, lasting 4 minutes and 38 seconds. The magnitude 9.2 megathrust earthquake remains the most powerful earthquake recorded in North American history, and the second most powerful earthquake recorded in world history. As a result of the earthquake, across south-central Alaska, ground fissures, collapsing structures, and tsunamis resulting from the earthquake caused about 131 deaths. Two types of tsunamis were produced by this subduction zone earthquake. There was a tectonic tsunami produced in addition to about 20 smaller and local tsunamis. These smaller tsunamis were produced by submarine and subaerial landslides and were responsible for the majority of the damage. Tsunami waves were noted in over 20 countries. Number 3. The 2004 Indian Ocean earthquake and tsunami occurred at 58 hours 53 minutes UTC on 26 December, with an epicenter off the west coast of northern Sumatra, Indonesia. It was an undersea, megathrust earthquake that registered a magnitude of 9.1 to 9.3. A series of massive tsunami waves grew up to 30 meters high once heading inland. After being created by the underwater seismic activity offshore, communities along the surrounding coasts of the Indian Ocean were severely affected, and the tsunamis killed an estimated 227,898 people in 14 countries. The earthquake was the third largest ever recorded. It caused the planet to vibrate as much as 10 millimeters, and it remotely triggered earthquakes as far away as Alaska. Number 4. The 2011 earthquake off the Pacific coast of Tohoku, Japan, was a magnitude 9.0 to 9.1. Undersea megathrust earthquake off the coast of Japan that occurred at 05:46 UTC on Friday 11, March 2011. It was the most powerful earthquake ever recorded in Japan, and the fourth most powerful earthquake in the world since modern record-keeping began in 1900. The earthquake triggered powerful tsunami waves that may have reached heights of up to 40.5 meters, and in the Sendai area traveled at 700 kilometers per hour. Residents of Sendai had only 8 to 10 minutes of warning, and more than 100 evacuation sites were washed away. The tsunami swept the Japanese mainland and killed over 10,000 people, mainly through drowning, though blunt trauma also caused many deaths. The latest report from the Japanese National Police Agency report confirms 15,899 deaths, 6,157 injured, and 2,529 people missing across 20 prefectures, and a report from 2015 indicated 228,863 people were still living away from their home in either temporary housing or due to permanent relocation. Early estimates placed insured losses from the earthquake alone at $14.5 to $34.6 billion. Number 5. The 1952 Kamchatka earthquake. The main earthquake struck at 16:58 GMT on November 4th, initially assigned a magnitude of 8.2. The quake was revised to 9.0 in later years. A large tsunami resulted, causing destruction and loss of life around the Kamchatka Peninsula and the Kuril Islands, Hawaii. was also struck, with estimated damage of up to $1 million in livestock losses, but no human casualties were recorded. Japan reported no casualties or damage. The tsunami reached as far as Alaska, Chile, and New Zealand.
Okay, we've just watched some very deadly short cuts from some scenes.
Can I watch the name? The number 3 and number 5. I cannot watch the name.
Mm.
Number 3. The 2004 Indian Ocean earthquake and tsunami occurred at 58 hours 53 minutes UTC on 26 December, with an epicenter off the west coast of northern Sumatra, Indonesia.
This is Indonesia.
Number 5 and number 1.
Number 1 too?
Yes.
Of the largest earthquakes in history, earthquakes are caused by movements within, except by sensitive instrumentation, to sudden and violent. Number 1. The 1960 Valdivia earthquake. Various studies have placed it at 9.4 to 9.6 on the moment magnitude scale. It occurred in the afternoon on May 22nd.
And number 5, right?
Number 5.
At 1658 GMT. At 16. The main earthquake struck at 1658. The earthquake. Number 5. The 1952 Kamchatka earthquake. The main earthquake struck at 1658 GMT on November 4th.
Okay. The first one is the Chile earthquake in 1916, about 9.4 to 9.6
magnitude.
Yes. Number 2 is 1964, about 9.2 magnitude, 131,000 deaths. The 2004 Indian earthquake, about 9.1 to 9.3 magnitude. Number 4 is the 2011 earthquake, about 9.0 to 9.1 magnitude. Cause of 40.5 meter tsunami. The last one is the Kamchatka earthquake, about around 9.0 magnitude. Cost $1 million are affected after this earthquake.
Okay. Did you turn on the CC and then you write down?
What?
Is that you turn on CC on Google Meet?
No.
You turn the subtitle at the up. Turn the subtitle on, right?
No.
No? Okay. No, I'm just asking. Yeah. So it's good?
Yes.
Yes, it's nice. So, which one is youth? So what kind of damages that earthquake can cause to humans?
Gọi là kinh tế là gì cô?
Economy.
Yeah, economy. Economy, debts, the environment, buildings got destroyed. I think that's all.
That's all. Can you give a little bit more details, like when an earthquake's taken place? So what happens?
What?
When an earthquake takes place, what happened?
The earthquakes only take place for about 3 to 5 minutes, but it causes
Mm.
a, a lot of effects. It can affect the volcano and cause a tsunami.
Okay. Yes, it's mostly
Like
cause the tsunamis.
studied to yesterday, the Fuji mountain is
Mm.
actually an active volcano, and
Mm.
if if the earthquake has more than 9.0 magnitude
Mm.
happen near Fuji mountain, it will erupt,
Again. Yeah, erupts again.
erupt, and Japan, uh, Tokyo will be destroyed.
Oh my God. Yes, that's so scary, right? Mm-hmm. Okay. So can we predict earthquakes?
Yes.
Yeah.
Mm, mm,
What do you know about prediction for earthquakes? You tell me.
I don't remember a lot, but I
Mm.
remember they use the cảm biết là gì cơ?
Sensors.
Yes, some sensors
Sensors.
to and put them uh, above the ground for about 10 meters, and it would be predict. I read it in a book and it said so, but I don't remember a lot.
Mm. That's nice. If you read some books like that. Here I have a map of earthquake prone country. It mean that some areas that easily to have earthquakes. Okay, I think
Mm.
this one is. Okay, so have a look at the map.
Vietnam are in the map too.
Mm. So you can see that night above, like 7 to 8.9. Yeah, so Vietnam is like slightly 7 to 8.9. Mm. Okay.
But I haven't saw some big earthquakes in Vietnam.
Yes, luckily. So yeah, throughout the maps, this one, can you mention some kind of most earthquake-prone countries in the world?
Mm.
So like top number one would be.
The USA and the Alaska. I can see in the North American,
Mm, but like on the west side or the east side?
the, the west side.
The west side. Yeah, that is. You see, most of the Americas is north and the south. Uh, all of the west sides usually include the most earthquake-prone countries, right? Yeah. Okay.
Uh,
You know vành đai lửa, vành đai
nào
lửa Thái
nào,
Bình Dương.
lại gì cơ?
Like I think it's Pacific Rim or something. Yeah,
Pacific Rim.
kiểu nó là cái nơi mà hai mảng kiến tạo, nó là nơi hai mảng kiến tạo liền nhau á con, nó hay va chạm với nhau á. Yeah. So that's the one, like that's why like Japan is on the edge of those tectonic plates là mảng kiến tạo á. So that's why they, yeah, very most very earthquake prone. Okay, can you name other countries in the map too?
Hmm?
Yeah, just tell me, what can you know from the map? Just tell me.
The Japan, the Indonesia.
Sorry, it's not Pacific Rim. Pacific Ring of Fire. You see?
Mm.
Pacific Ring of Fire. Yeah, this one.
the Philippines, the Indonesia. Mm, what's, uh, what is number 7? The New Zealand, the New Zealand.
Number 7 is the New Zealand.
So my geography is enough good.
Uh-huh. Okay.
Uh, the India.
Mm. How about number 2?
It's to India. Nepal. Nepal.
Mm-hmm.
Con nhớ là cái Nepal là nó ở bên cạnh Ấn Độ mà hai nước nó nghèo giống nhau. À không phải là nghèo, cũng đúng.
Like
Nó
they
giống nhau.
yeah, they have the same kind of religion, right? Nepal. Mm.
Mấy gì đâu bộ.
Mm.
Ờ, còn chắc là có thêm ở bên Nam Mỹ thì có thêm cái Argentina với lại Mexico.
Yeah, it's Mexico. Peru. Number 11 is here, Peru. Okay, number 10 is Mexico.
Okay.
Yeah, number 4 is like Chile. Chile. Okay. Yes. So you can see like from this map, you can see that some area on Earth are more easily to have earthquakes than the other places.
Còn mấy kia con không biết.
Yes. Okay, but it's nice. Yeah. Now I have a reading for you to read. Is prediction possible? Now can you read?
Is prediction possible? Never before have so many people been packed into cities, places such as Los Angeles, Istanbul, Tokyo, and Lima. They are regularly affected by earthquakes. Located near the edge of Earth's huge shifting plates, these cities face the risk of serious damage and economic disaster from
Economic.
large quakes.
Economic.
Economic
Mm.
disasters from large quakes, as well as tsunamis, fires, and other kinds of destruction they often cause. We understand earthquakes better than we did a century ago. Scientists would like to be able to predict them, but is this possible? Today, some of the simplest questions about earthquakes are still difficult to answer. Why did they start? What makes them stop? Perhaps more or the most important questions scientists need to answer is this: are there clear patterns in earthquakes, or are they basically random and impossible to predict? In Japan, government scientists say they have an answer to the questions. We believe that the earthquake prediction is possible, says Kaoshun Yamaka, a scientist at the Earthquake Research Institute at the University of Tokyo. In fact, Japan has already predicted where is the next great earthquake will be. The region of Tokai southwest of Tokyo. Here, two plate boundaries have generated huge earthquakes every 100 to 150 years, but there has been a major earthquake since 1854. The theory is the stress is building up in this zone, which could lead to a massive quake. Unfortunately, this is more forecast than a prediction. It's or one thing to say that an earthquake is likely to happen in a high risk area. It's another to predict exactly where and when the quake will occur. A desire, a desire for a
Precise.
precise prediction of time and place had led to another theory, the idea of Presley. Nayuki Kato, a scientist at the Earthquake Research Institute, says his laboratory experiments show that before a fault in the Earth's crust finally breaks and causes an earthquake, it's just a little. If we can detect these early slips taking place deep in the Earth's crust, we may be able to predict the next big quake. Clues in the desert. Scientists working on in Parkville, California,
Keep going.
are also trying to see if predicting earthquakes is possible. They have chosen the town of Parkville not only because the San Andreas Fault runs through it, but because it's known for having earthquakes quite regularly, approximately every 10 to 2 years. In the late 1980s, scientists in Parkville decided to study the fault to see if there were any warning signs prior to a quake. To do this, they drilled deep into the fault and set up equipment to register activity. Then they waited for the quake.
Hmm. Okay, there are some vocabularies here. Can you have a look and ask me?
Go xuống nhiều
Yes. Okay.
cái precise là gì cô?
Precise is mean exact.
Exact.
Yes. Precise prediction is mean exact predictions. Okay. Yeah. Any other words?
Institute là gì cô?
Which one?
Institute Earthquake Research Institute nhóm thứ
Oh.
hai.
Okay. Institute is mean like viện.
Viện.
Yes. So it's Earthquake Research Institute mean viện gì con?
Nghiên cứu động đất.
Yes, that's right. Very nice. In my university, Cần Thơ University, there is a RISE, RISE Research Institute.
Wow, wow what?
No, RISE Research Institute. Viện nghiên cứu giống lúa con.
À, tự nghiên cứu cơm.
No, yeah, rice seeds. Yeah, Research Institute. Okay, anything else?
No.
How about detect?
Phát hiện.
Yes, that's good. Massive?
Bự.
Okay. So what is the difference between a forecast and a prediction?
Forecast là đánh bừa. Prediction là dự báo.
It's you swap the role and then it's correct. Con đổi lại mới đúng con ha. Yeah, prediction is like oh. Wait.
Là prediction là đánh bừa, forecast là dự báo.
No, here two plates batteries have generated huge earthquakes every 100 to 150 years. but there hasn't been a major quake here since 1854. The theory is that stress is building up in this zone, which could lead to a massive quake. Unfortunately, this is more a forecast than a prediction. It's one thing to say that an earthquake is likely to happen, it's another to predict exactly where and when the quakes will occur. So, which one? Forecast and prediction, what is the difference? Forecast là gì và prediction là gì vậy con?
Một cách là đánh bừa, mình là dự báo.
No, you swap it. Nếu con đổi lại mới đúng nha con. Forecast mới là dự báo nha con. Còn prediction là dự đoán. So maybe it's not, there's no data. No data. But forecast, you have data. Okay? Yes. Okay, that's it for this one. You keep going. Can we leave the threat?
There you go.
Okay, as you know, there are some countries in the world that are very prone to earthquakes. So, how can they live with the threat? Can you tell me some methods that the city can survive?
Threat là gì? Ý là câu hỏi là threat là gì?
Threat là mối đe dọa.
Thấy Nhật người ta sống mối đe dọa mà người ta vẫn giàu đó.
Yeah. So, is there any ways for that? Tell me your opinion from what you know.
Because they're good. They're so pro.
So, how can they do that?
They're smart. They adapt. They make the problem become normal.
How? That's what I want to ask you. How?
Use machine, buildings, a wood house. Building a wood house to reduce the cost of economy after an earthquake.
Okay, all right. Yeah.
They predict the natural disasters soon and warn it to their người dân là gì thưa cô?
The residents.
The residents.
Okay.
So they can prepare.
They can prepare for that. So what I want to ask is like the technique. You mentioned some. You say that they build the house with wood. They don't build the house with too much concrete and too many bricks, right? Anything else that you know about the technical things that Japanese cities can survive with the earthquakes? So first is the material, right? The materials is wood. They use different kind of materials, right? And anything else? Okay, it's okay. You can watch this video. In this video, they will show you how Tokyo can survive earthquakes. And there's some techniques that they can use. Now, can you take notes some techniques that they use?
How do you build a tower rising to 634 meters right in the middle of Tokyo, on land that was once the soft seabed of an ancient bay, in a city that endures around 1,500 earthquakes every year? That was the challenge Japanese engineers had to solve when constructing Tokyo Skytree, the tallest broadcasting tower in the world when it was completed in 2012. To keep this superstructure standing proudly on the Pacific Ring of Fire, they fused the balancing mechanism of 1,300-year-old wooden pagodas with NASA space technology. The result was an architectural masterpiece soaring into the sky, one that not only shattered height records, but also became one of the strongest survival fortresses standing in the heart of a high-risk megacity. And in today's video, join Mandarin Tech as we explore and decode the unique technologies hidden inside the tallest freestanding tower in the world, Tokyo Skytree. Tokyo is one of the largest megacities in the world, where more than 35 million people live across an urban region that has continued expanding for many decades. For many years, the Japanese capital's television broadcasting system depended primarily on Tokyo Tower, a structure rising 333 meters that was once sufficient to cover the entire area when the city's skyline was still relatively low. But as Tokyo entered the 21st century, its urban spatial structure began to change rapidly. High-rise buildings kept rising one after another, weakening signal transmission, especially when Japan shifted to digital terrestrial television broadcasting, which required a far higher level of signal stability than before. And Tokyo Skytree was the answer, a superstructure rising 634 meters, becoming the third tallest freestanding structure in the world, with an observation deck at a height of 450 meters designed to ensure stable broadcasting coverage across a range of up to 100 kilometers. Elements were erected, engineers had to confront a fundamental challenge. The entire structure was built on soft sedimentary layers that once formed part of the ancient Tokyo Bay, where the ground mainly consists of mud and weak soil with very low bearing capacity. Due to the enormous height of the structure, the entire tower behaves like a gigantic lever under the influence of wind and earthquakes. When oscillation occurs, one side of the foundation is subjected to large compressive forces, while the opposite side experiences tensile forces. Therefore, the foundation system must not only carry vertical loads, but also resist extremely large overturning moments generated by the structure itself. To control these uplift forces, engineers applied the principle of friction pile foundations. This technique had already proven effective at the Ferry Building in San Francisco, completed in 1898, where 5,000 timber piles driven approximately 55 meters deep into the mud successfully supported a structure weighing 75,000 tons through major earthquakes thanks to friction with the surrounding soil. At Skytree, this principle was implemented on a more advanced scale through a system of 131 reinforced concrete wall pile foundation elements arranged in a triangular layout beneath the base of the tower. Tokyo Skytree uses a triangular...
Because this video is too long, so I will skip to just some key points of this one. So the things that you are listening to is the foundation technique. Cách làm móng. Okay, so the next one.
Hey everyone, in this
challenge facing Tokyo Skytree came from site constraints. The engineers had to design a tower twice as tall as Tokyo Tower, yet place it on a site with only 1/4 of the footprint area. This pushed the structure's slenderness ratio to 9:1, causing the tower to face a serious risk of instability under wind loads. To solve this problem, the project adopted the principle of X-bracing, a breakthrough in skyscraper design developed by engineer Fazlur Khan for the John Hancock Center in the 1960s. These structural systems allow wind loads to be distributed efficiently through the outer load-bearing skin rather than being concentrated in the central core. Applying that principle, Skytree's outer load-bearing structure was assembled from 37,000 high-strength steel components. At the base of the tower, steel tubes with a maximum diameter of up to 2.3 meters and a thickness of 10 centimeters were used. The key point is that this entire structural skin was formed from thousands of open triangular space trusses. From a mechanical standpoint, the triangular form is exceptionally effective at preserving its shape under lateral forces. At the same time, the open truss design allows air to pass through the tower body, thereby minimizing the direct wind pressure striking the surface. Japan lies on the Pacific Ring of Fire, one of the most seismically active regions in the world. On average, the Tokyo area records around 1,500 tremors of varying intensity each year. For a structure rising to 634 meters, seismic motion not only causes lateral displacement in the tower body, but also creates the risk of triggering resonance between the ground and the structure if not properly controlled. To limit the overall vibration of the structure, Tokyo Skytree uses a central concrete core called Shinbashira, a structural solution inspired by traditional Japanese pagoda towers. This concrete core has a diameter of about 8 meters and extends to a height of around 375 meters inside the tower body. Within the first 125 meters measured from the foundation, the Shinbashira core is directly connected to the outer steel structure in order to increase the overall stiffness of the lower part of the tower. Above that elevation, the concrete core is no longer rigidly connected, but is linked to the steel structure through an oil damper system, allowing the two structural systems to vibrate out of phase when an earthquake occurs. This phase difference helps cancel out part of the vibrational energy transmitted through the tower body. Calculation models and tests show that the Shinbashira system can reduce the overall displacement of the structure by up to about 50% in the event of a strong earthquake. In addition to the central core system, Tokyo Skytree also uses Skytree's next challenge was maintaining geometric stability at the top of the tower, where the main broadcasting antenna is installed at a height of more than 600 meters. At elevations of about 620 meters and 625 meters, Tokyo Skytree was fitted with two tuned mass dampers weighing about 40 tons and 25 tons. These devices oscillate out of phase with the movement of the tower structure, moving in the opposite direction to the antenna's vibration in order to cancel out part of the vibrational energy caused by strong winds at heights of around 600 meters, thereby stabilizing the broadcasting zone at the top of the structure. In addition, around the observation decks at heights of about 350 meters and 450 meters, the enclosure structure uses more than 10,000 multi-layer laminated glass panels capable of withstanding wind speeds of up to about 100 meters per second. These glass panels not only ensure safety for the tourist areas, but also maintain air tightness and pressure stability against wind loads at the functional floors located in the upper part of the structure. Thanks to the combination of the tuned mass damper system at the tip of the antenna and the wind load control solution, when Tokyo Skytree officially began the damper system at the tip of the antenna,
Okay, I hear that. Yeah.
uses more than 10,000 multi-layer laminated glass panels capable of
So từ đầu của cái này luôn phải không con? Fine adjustment. Okay.
Once it passed the 400-meter mark, Tokyo Skytree's next challenge was maintaining geometric stability at the top of the tower, where the main broadcasting antenna is installed at a height of more than 600 meters. At elevations of about 620 meters and 625 meters, Tokyo Skytree was fitted with two tuned mass dampers weighing about 40 tons and 25 tons. These devices oscillate out of phase with the movement of the tower structure, moving in the opposite direction to the antenna's vibration in order to cancel out part of the vibrational energy caused by strong winds at heights of around 600 meters, thereby stabilizing the broadcasting zone at the top of the structure. In addition, around the observation decks at heights of about 350 meters and 450 meters, the enclosure structure uses more than 10,000 multi-layer laminated glass panels capable of withstanding wind speeds of up to about 100 meters per second. These glass panels not only ensure safety for the tourist areas, but also maintain air tightness and pressure stability against wind loads at the functional floors located in the upper part of the structure. Thanks to the combination of the tuned mass damper system at the tip of the antenna and the wind load control solutions around the observation decks, Tokyo Skytree is able to maintain the geometric stability required for the broadcasting system at a height of more than 600 meters before fully serving its role as a strategic communications infrastructure within Tokyo's urban information network.
Okay, that's it for the technical things. The rest is just like the meaning and the role of the tower, but it's not about technical. Okay? So can you share with me?
The first one is spies predicting. It makes A shape is the triangle.
Mm. And why do they use the triangle? Is not the rectangle or square?
And you can watch it. It is the back of the part.
Like you haven't heard of that, right? Oh, they say that because the triangle is like the most stable shape ever. Yeah. Even the shape of the pyramids have the four sides.
Stable là gì cơ?
Stable là ổn định đó con. Yeah.
Nó trong này có nhiều từ khó con nghe không có được.
Đúng rồi, thì cái này là về kỹ thuật mà nó hơi khó con. So they say that a triangle is like the most stable shape that we can use in construction. Even the pyramids in Egypt, they use uh, the pyramids that have four sides of the obsolete triangle, hình tam giác cân đó con. Bốn mặt là hình tam giác cân, oscillate triangles. So because they are very stable. Okay. Yeah. The first point is that. The second point. That is the first point. Okay. How about the second point?
Từ nãy con nói là cái pie còn kicking á cô. Cái đó là cái khác nữa. Cái đó là cái móng nhà, còn thì còn cái móng nhà nó là triangle.
No, móng nhà.
Còn cái cô đang nói là nó là cái hình dạng của cái tháp mất tiêu rồi.
Là mấy cái phần khung ở trên, khung thép ở trên đúng không con? Còn cái móng.
Nãy giờ con nói còn nãy giờ con nói là nó là cái khung á, nó là cái móng á.
Oh, if it's the foundation, it's not the triangle. It's a lot of poles.
No, con mới nói là piles concreting mà.
Pile concreting?
Yes, piles concreting.
So the triangle is the second one, right? So both, you mentioned two of them already, right?
Yes.
Yeah, okay. So number 3?
Concrete core inspired by traditional buildings.
What do you say? You can say again.
Concrete core inspired by traditional building.
Okay. How about number 4?
Use wind to move. There's a core that use wind to move opposite sides of the tower and produce energy. Its weight is 40 tons. In addition, it uses 10,000 layers glass panels.
Okay. The number 4 one, you hear a lot of details. That's nice. Yeah. So now you understand how their constructions helps in the surviving earthquakes. Yeah. Okay. You have 5 minutes break.
I'm back.
Yes. Okay. All right. So, yes. Like I have a like discussion with you now. If you were a government decision maker in an earthquake affected country, which of the following would you prioritize?
Juggle.
Yeah, these things. Okay, I have a mini question for you. If you were a government decision maker in an earthquake affected country,
Prioritize là gì con? Lựa
Pri-
chọn.
prioritize like ưu tiên á con.
Ừ.
Yeah. Which of the following would you prioritize? Reinforcing old buildings or educating,
Reinforcing là gì con?
là gia cố lại, làm cho chắc chắn lại.
Educating a public on earthquake city.
Yeah. Ensuring new buildings are earthquake proof and researching ways to predict earthquakes. So which one would you prioritize?
Ừ.
Like, should we try to save what we already got? Or should we try to like rebuild some new buildings that are more modern? uh Or we just like train people how to survive? Or we just like predict it well? So which one do you think it's the best for an earthquake affected country?
Told people to go to another place that are safe and reinforcing the old buildings.
So it means that you have other ideas and reinforcing older buildings. Ah. Can you explain more, like going to other places? What does it mean? Like they
Like
leave.
maybe I'm in Vietnam
Mm.
and maybe Kon Tum or Đắk Lắk got an earthquake,
Mm.
and I and the government, instead of researching way, I can met and told met or told some expert to researching.
Some safer places.
Yes, some safer place like in Đắk Lắk, I can show local people to move to a lower place to avoid the sạt
The
lở là gì cô?
the landslide.
The landslide.
Oh. Oh, but the landslide is a different thing. It doesn't have anything to do with earthquake.
Động đất là phải có sạt lở cô, chứ cái đợt vừa nó nó nó, nó cái động đất là nó có rung chuyển là toàn bộ mọi thứ nó đều có thể đổ sập là ấy.
So you can think that earthquakes cause landslide, but landslides not
Có thể
always.
kêu có thể kêu là người dân trong tỉnh đó là di chuyển qua tỉnh lân cận để tránh cái vụ động đất, và sau đó là tra cứu những cái nhà cửa cũ của người dân ở đó. Thì để cố gắng là giữ tài sản này cho họ. Sau này mình đỡ phải bồi thường.
Okay, because you government decision maker, right? Okay. So do you think that everything you just mentioned just can be done well with the good prediction?
Yeah.
Yeah. Okay. So your final decision would be what's the method?
My own decision
Mm.
because we can the prediction for I can force the mission of predict the earthquake for some experts.
Okay. Some experts.
Some experts. I'll give them some money to buy some sensor or
Equipment.
everything that is the best thing to predict the earthquake. Everything they need to predict the earthquake.
So you mean the most modern equipment?
Yes.
Right.
And if they predict right, I will give them some money as a present.
The bonus. The present.
If they predict wrong, province will earthquake will cause a lot of deaths and they have to
Compensate. Bồi thường.
bồi thường chịu trách nhiệm.
Compensate. Take responsibilities.
Yes.
Okay. Yep. You need some vocabularies to use. Okay. You know the word compensate?
No.
Yeah. You can write down so then you can say.
Nhưng mà viết sao cơ?
C-O-M.
Lười quá.
C-O-M.
Con.
C-O-M.
Em.
Yeah. P-E-N. S-A-T-E.
Compensate.
Yeah, compensate.
Là gì cô?
Bồi thường. Okay? Yeah, keep saying. Your old idea is that like relocating residents and reinforcing old buildings. You talk about that more? The relocating people.
Nhưng mà ý là con nói hết ý của con rồi, con không còn cái gì để nói nữa.
You have any ideas to add in?
No.
Okay.
Nothing.
Nothing.
I'm not government. I'm a kid.
Okay. Yeah, I know that you're a kid. You are a kid. But I want to see your view. Yeah. Okay. So yeah. Now you keep going with the grammar. Clauses of contrast, purpose, reason, and result.
Good.
Yes. Send you the link. You share screen. How many hours have you learned today? How many classes have you got today?
0. But I have to do my homework today. A lot of homework.
Today I see that your energies is a little bit going down. Is that right?
Yes.
Yeah. Because of the homework?
Maybe.
Okay. bên đây nha, đừng có để tôi thấy nha con. Con đứng là đứng bên đây. Thôi con ăn đi, mẹ không ăn đâu. Con ăn đi. Ăn nhỏ tí thôi nha. Để xuống dưới ăn đi. Không được con. Ổn nó ra ngoài đi.
Yes.
Finally,
Mm.
is it very challenging?
What?
Is it very challenging?
Yes.
Yeah, okay. These are the linkers. Okay. Now, number one, can you explain why you choose that one?
Because it's at the comma.
Mm,
Comma.
okay. Yes. Number two.
In.
So why it's not because of?
Con không biết nè, con lên cản cẩn này.
Tại vì cái mối quan hệ giữa hai cái clause này nó không phải là nguyên nhân kết quả, cho nên mình đâu có chọn because of được. Ok. Cái kia là một cái trường hợp đối kháng với cái đằng trước. Number 3. Why is for?
Là có verb in.
Due to thì đằng sau cũng verb in được. Tại sao lại không due to vậy con?
Con không biết nè, đề nó cây vậy, con cái gì?
Không, có nghĩa là khi mà con chọn con cần biết mấy đáp án kia tại sao nó không được. Lúc này thì nó nằm ở nghĩa con.
Nghĩa là sao?
Câu số 3 ấy.
Nghĩa.
Sao thấy đơ đơ vậy ta? Sao giống hết vô quá vậy?
Tất cả hết pin rồi coi.
Cái giờ pin low battery, please charge now. Ok, number 3 gán lên xíu nó đi con.
Gán lên.
Yeah, được mà. Ăn cơm chưa? Ăn cơm buổi trưa chưa?
Đây rồi.
Có ngủ trưa không?
Một xíu.
À, không, vậy thì là ổn á con. Tại cơ thể con đang làm biếng thôi. Number 3. Tại sao lại không due to được? Còn to với so is to chắc chắn là không được rồi ha. Tại vì hai cái này đằng sau phải là mình làm từ nguyên mẫu ha. Nhưng mà cô đang hỏi due to tại sao không được?
Nếu nói là something is used for, tức là cái này nó dùng để làm cái gì thì cái này cái for này nghĩa là để.
Các nhà khoa học mới phát hiện ra một cái phương pháp mới để mà đo lường tốc độ mà vũ trụ đang giãn nở. Hay là các nhà khoa học đã phát hiện ra một kỹ thuật mới bởi vì đo lường tốc độ giãn nở vũ trụ.
Tại cái này là bởi vì nó là kết quả rồi.
Đúng rồi, nằm ở nghĩa đó con. Ok, number 4.
Technological advance. Thì cái này nó vì cái này cho nên là nó mới có cái này, chứ nó không có đối xứng như despite hay là sin hay as.
Sin với as cũng có nghĩa là bởi vì mà. Despite chắc không được rồi ha, nhưng mà sin với as cũng là bởi vì luôn. Tại sao không được? Có hai nghĩa đến ngữ pháp. Đằng sau sin với as thì nó phải là gì?
Cấp 2.
Chết rồi, sao mà lộn xộn hết rồi. Sau sin với as thì giống như because thôi, đúng không?
Mấy cái này nó cứ lộn xà vàng hết.
Kể cái bảng đi. Bữa nay học xong kể lại cái bảng cho cô. Lưu lại hai cái link này đi, xong rồi con tổng hợp kể lại cái bảng cho cô. Yeah. sau sin với as với because of đều có nghĩa là bởi vì, nhưng mà sin với as thì đằng sau là nguyên một câu đầy đủ. Còn because of là cụm từ, cụm danh từ. Ok. Này dễ à con, chỉ là điều nó nhiều với lại con phải phân nhóm nó thôi chứ nó dễ, không gì khó hết ha. Rồi thế thì hôm nay nè con, bài tập hôm nay cô sẽ không có giao bài mới cho con, mà cô giao cho con vẽ cái bảng tổng hợp cái này á. Được không? Đó, cô sẽ gửi cho con cái link này nha. Rồi, number 5.
Can the people ask better question as a result they get better answer? Thì cái này là thế là phải hỏi, con thấy ask a result tức thấy nó giống for cái gì á,
Kết quả.
nó cũng tới một cái kết quả đó.
Con ngại gì mà không dịch ra, con dịch ra nó dễ, biến mọi thứ dễ hơn rất nhiều. Người thông minh hỏi những câu hỏi tốt và kết quả là họ có câu trả lời tốt hơn. Ok.
Only some prisons have been closed in Ireland due to a lack of prisoners. Due to cộng với cụm từ, cụm danh từ.
Ở đây thì về nghĩa thì có because và cho cô xem lại câu trên đi con.
Câu 6, câu 7.
Câu 6 thì là có A với B, because và due to là hợp nghĩa, đây là bởi vì con ha. Nhưng mà vì cái dấu cụm đằng sau cho nên con chọn due to.
He asked a stupid question, so I gave him a stupid answer. Con đọc cái này nó là so thì nó là chỉ kết quả, là so cộng subject cộng verb.
Đúng rồi. Thế còn so that thì sao?
So that nó không là kết quả
mà là gì?
Mục đích.
So that là để mà thì là mục đích rồi. Number 8.
Trước danh từ thì dùng cái owing to.
Nhớ này là con, đối với những câu này thì con sẽ chọn về nghĩa trước. Mình sẽ chọn cái nghĩa trước nha, để mình loại bỏ những từ không có phù hợp với nghĩa. Sau đó thì mình mới nghĩ đến ngữ pháp. Meaning first and then grammar. Đấy. So meaning câu này là công ty phải đóng cửa gì đó, sự sụt giảm trong lợi nhuận. Thì đây mình có mặc dù, bởi vì, để mà, vậy thì mình sẽ bỏ cái nào?
Cái owing to.
Mình bỏ cái mặc dù despite, mình bỏ cái so that để mà ha, chỉ còn hai cái là B và C, là bởi vì công ty đóng cửa bởi vì lợi nhuận sụt giảm, thì chỉ còn B và C. Sau đó mình mới nhìn đến ngữ pháp.
Cái này nó là cụm danh từ.
Cho nên mình chọn owing to nha.
Cộng subject cộng verb.
Con lại ngữ pháp trước rồi cho cô cái nghĩa trước đi con, rồi cái ngữ pháp.
Ngữ pháp hả?
Ngược nghĩa trước.
Owing to thì nó nghĩa là
không, nghĩa là nghĩa của cái câu trước con, để mình biết từ còn thiếu sẽ cần phải là nghĩa gì.
Nó là trễ. Sau đó chúng tôi đã quyết định để đây có cái nhiệm dịch vụ phòng và xem một bộ phim.
Vậy thì sao? Nó trễ nên chúng tôi quyết định là dọn phòng, có dịch vụ phòng đó, dịch vụ dọn phòng và xem phim. Như vậy thì là bởi vì nó trễ hay là tuy nhiên nó trễ?
Bởi vì.
Bởi vì thì con sẽ bỏ đi được đáp án nào?
However.
However, mình còn A, B, C, lúc này mình mới chọn đến ngữ pháp.
ABD mà cô.
Mình còn ABD, yes, đúng rồi. Sau đó mình mới chọn đến ngữ pháp. Thì làm sao? It was very late là câu hay là cụm?
Là cụm.
It was very late là câu hay là cụm?
Câu.
Câu thì mình đi với cái nào?
Con mình đi với as.
As thôi ha, tại vì owing to, because of là đi với cụm mất rồi. Đó. Yes. Logic hơn chưa? Number 10.
Take the map in case we get lost. Tức là hãy đem cái này với thì cái này nó có mục đích để phòng hờ
Trong trường hợp
chúng ta bị lạc.
Thì sau in case thì là một câu bình thường. Còn sau for thì là
câu verb in.
Sau in order to là
bình thường.
verb không. Ok. Sau so thì lại là chỉ chờ để mà rồi là kết quả rồi ha. Ok. Rồi thế thì về nhà là cô chỉ cho con cái cách mà tổng hợp cái bảng nè. Thì con xem cái phần explanation, con lướt lên. Có 3 cái tab đó con, exercise, explanation, download, được chưa? Thì cái phần explanation là cô giải thích cho con rồi, thì con tổng hợp nó xuống. Nhưng mà phần explanation này không có đủ. Trong exercise có nhiều kiến thức hơn nữa. Con bật qua tab exercise đi. Hình như con kéo xuống dưới thì có bảng kìa con. Bên explanation có. Vậy là nó đủ luôn đó con. Kéo xuống nữa cho cô. Có. Ok. Đó. Rồi làm cho cô một cái bảng thôi duy nhất, chứ đừng có kể nhiều bảng hết. Và sắp xếp cái bảng sao cho khoa học để mình học nhé.
Ok.
Vậy là nằm trong đây rồi đó con khỏi lật qua exercise.
Ok.
Rồi. Còn bài của hôm qua thì cô vẫn giao bài tập nha. Yes.
Ok.
So, goodbye for now.
Goodbye.
Ôi chao, nó còn
Con nhìn nhanh hương như một tóc.
thôi ăn uống gì ăn xong đi rồi cất ly đi con.
Trời ơi, nãy giờ tóc. Mẹ ơi, mẹ gọi anh này nghe con. Có người gì vào nhà mình vậy? Cha!
Cất ly đi. Mở một tóc ra chi vậy?
Mở ra đây con buộc lại con ấy chưa có gọn.
Chứ gọn hả? Cột kia này
Con
gọn
muốn-
dữ rồi.
Con muốn giống gọn mẹ với mẹ này mình làm quá gọn.
Lau chung sức công.
Mẹ ơi,
Bình.
mẹ.
Cất chén đi.
Mẹ ơi. Con ngắt nước.
Cất chén đi. Cất chén heo đi con.